Good morning to all. In this video we are going to perform or overview the bit bank SPI code for the FMD chip. As we already know, the cost-effective solution for the 8-bit is a FMD chip. And if you remember, or if you have seen my earlier videos regarding FMD chip, there are lots of low-cost 8-bit microcontrollers from the FMD chip that some has some hardware-based peripherals like UART, I2C, then SPI, and other things as well. But some of them doesn't have any hardware for the I2C, then SPI and UART. So for those that require the SPI and I2C using the software, and the technique is called the bit bank, means we are sending bit by bit or receiving bit by bit. So we are targeting the serial EEPROM based on the SPI, the 2564. Okay, so for the SPI we need 4 lines: the clock, chip select, okay, clock, chip select, SI, SO. So to control this SPI chip, there are some certain instructions before we need to send for the write, read. Okay, so mainly there are some instruction for like this is for 3 means read instruction, 2 means write instruction, 6 means set the write enable latch. There are some certain area we can protect that area as well. Let's say we want to disable the write operations, so that there will be some specific pin for that WP, or using the internal instruction we can have the write enable or disable. Okay, so for write enable we have 6, for reset the enable we have 4 instruction value. Then we need to read the status, so for that it is a 5, for write status it is a 1. Okay, so the instruction signaling will be look like this for sequences. So as soon as the chip select goes low, we have to send the first instruction. As we know, for the read it is true. After that we have to place the address. Okay, after the address we can send the data on the SO. No, I think slave will send the data on SO. Okay, for the write it is the same thing. We have to send the instruction first for the write as a 2, provide the address of where we want to write, and then the data on the same SI line. Okay, so there will be some consecutive write process or sequences. In spite of the any breakage after the data, we have to continue write continuously data by 2, 3 up to the whatever the maximum possible page write within that particular target memory chip or SPI chip. It is not that it is for only memory. It is not like that. It is only for the memory. SPI protocols can be for ADC or any other peripherals. So in that also you can use this protocol signaling according to their data sheet, what kind of instruction and address we have to send accordingly. Okay, so more specifically we are referring for this tutorial 2564, so that is why I am explaining this little bit, so we can make back to our C code. I'm targeting the 62F13. It is a 8 pin. The A0, A2, A4 and C0 is used for the chip select, then clock, master out, slave input, master in, slave out. Okay. So as we already know from the I2C video, these are the header files. We need to define which pin for which signal of the SPI. Okay, the power initials, nothing but our initialization of the port using the trace and pull up arrangement. This is for initialization 2564. We keep this signal as it is. CS equal to 1 means it is disabled. Okay, this is for, okay, we go for this is for write enable. We know it is a 6. Write disable, it is a 4. Okay, according to this chart. Write enable 6, write disable 4, then read status 5. Okay, read status 5 and then write status 1. So in this way we can have send the instruction to the slave devices. Obviously there will be the write and read mechanism or subroutine for that. This is for read. Obviously we have to check whether it is busy or not. Send the instruction for the read. Upper 8 bit of the address, then lower 8 bit of the address. Then we can read the data from the slave. Similarly, we can have the for the write process, check whether it is busy or not. Make the write enable. Then we send the instruction for the write. Upper address, then lower address. Data which need to be write on that particular address. Okay. So these are, again we have to disable the write process and check for the ready status. So these are the subroutines for the bit banking of the SPI. You can use any series either from the FMD chip or any other like PIC or any chip you can use for this bit bank of SPI. These routines will be similar, will be there. Okay. And ultimately at the main we have to just initialize the 2564. Then for sake of simplicity I am reading the address 12 and just writing these what are the data I received. I just make the complement data and write on the 13H. Okay. So in this way we can implement the SPI in FDM chip. And I just back to this FMD ID where I put all this code. Just for overview, I just show the option for this. This is the name of the project. Location, I am selecting the 13X series. Compiler is C, FMD CC, the location of the compiler. Options are, these are the options. Settings are this. Okay, and you can just have the build process. In that there are various options according to your need. You can select that. Okay, just click OK. It will go through all the code and compile. And also give the summary for the, like, it will consume 5.5% of the whatever the available of the program memory. you are not using any EEPROM area. Data space is 3.9. So there are plenty of area remains there for other process. So in this way we can have SPI using this software based bit banking. So I hope this video finds useful to you. Please subscribe my channel and support me and hit like buttons. And if you want this code, I can put on Google Drive once you make a comment on this video. Thank you.